This is our new unit over angles and radians and the unit circle. And today is going to focus on just angles measured in degrees. Some of this will look familiar to you. It's concepts you've learned in previous geometry classes. Some of it will be new. So if I give you this angle right here that has the 3 letters on it, in geometry you learned that it had 3 names. We can call it angle B because that's its vertex. We can call it angle ABC, or we can call it angle CBA. Notice that in these 2 names, where you give all 3 letters, the vertex letter is in the middle. In trigonometry, angles have an initial side and a terminal side. Initial is the side that it starts, terminal is the side where it ends. The initial side always follows the positive x-axis, so your initial side is always going to point horizontally towards the right, and then the terminal side is where the angle ends after you've rotated it. What direction you rotate is dependent on the angle that I ask you to draw. In trig, a positive angle is always counterclockwise. So we start on the positive x-axis and we go around through to quadrant 2. If I ask you to draw a negative angle, that means we're going clockwise. So we're going to go down. So you will see angle 1. Here's its initial side. I just drew a random angle rotating counterclockwise. So that's my random positive angle. I also ask you to draw a negative angle. So once again, here's my initial side. This time I have to go clockwise. So I just rotated down, ended up in quadrant 3. One of the things I'm going to ask you to do is think through the coordinate system and figure out where is an angle going to end, in which quadrant. So here's a quick review of quadrants. They're numbered 1, 2, 3, 4. They go counterclockwise. 0 will start on the positive x. And since positive rotation goes counterclockwise, it's 90 up at the top, 180 off to the left, 270 underneath, and then we get back to 360 degrees. Using that idea, if I ask you where does a 230 degree angle end, if I look in this picture here, I know that 230 is more than 180, but smaller than 270, so it's going to end somewhere in quadrant 3. I'm not going to be concerned about where you draw this line if you choose to use the picture. I just want you to recognize it ends in quadrant 3. If I ask you to where 1,380 degree rotation ends, well, that means it's more than a full circle. One full circle is 360 degrees. So I have to figure out how many full circles this angle would rotate and then how much is left over. I can take out 3 full circles and then I'm left with 300 degrees. As I look at this picture up here, 300 is between 270 and 360. So it tells me it ends in quadrant 4. This is asking for a negative rotation. So I need to come down here and consider this example. If I'm going to go negative, that means I have to go clockwise. So negative 90 is at the bottom, negative 270 is up at the top. I have to go 580 degrees. Just to help me figure out how many times I went around the circle, I ignored the negative and just took off a full circle. That's 220. So this means I'm going around the circle, around the unit circle, 1 full time, plus an additional 220 degrees. So there's the full 220 is between 180 and 270, so we end up in quadrant 2. One of the terms we will use extensively is coterminal angle. Co as a prefix means together, terminal means end or terminate. So coterminal angles are angles that terminate at the same spot. So I want you to identify 2 positive and 2 negative coterminal angles, in this case to 50 degrees. Well, positive means this number needs to become more positive. Negative means I've got to make this a negative number. And I know that a full circle is 360. So if I add 360 onto 50, that gives me 410 degrees. That's my first positive coterminal angle. I'm going to add 360 onto that again, and that will give me 770 degrees. Here's the 2 positive coterminal angles. To go negative, I'm going to subtract 360. So that'll give me negative 310. If I subtract 360 from that again, I get negative 670. So there's the two negative coterminal angles. So you'll notice I've already worked out the others. Starting with 135, I've added 360 on 2 times to get these two numbers. I went back to 135 and subtracted 362 times to get these two numbers. I can ask you to start with a negative angle. To make it positive, I still have to add on 360, so I've done that 2 times. Negative means I just have to make it more negative, so I subtract 360 a couple of times and get these values. Did the same thing with negative 100, added on 360 or subtracted 360. So if I ask you for coterminal angles, I'm simply asking you to add or subtract 360 degrees from the given answer. Reference angle. The reference angle is the smallest positive angle that's coterminal to the given angle. So smallest positive, it means for our case it has to be somewhere between 0 and 360 degrees. So 450, well, that's bigger than a full circle. So if I subtract 360 from that, I end up with 90 degrees. 90 degrees is the reference angle. One person can rotate 90 degrees, someone else can rotate 450 degrees, and they're going to end up at the same spot. I simply had to take this number and make it smaller to fit between 0 and 360. 1,350, that's obviously bigger than 360, so I have to keep subtracting 360 until I end up with an answer that's within one rotation of the unit circle. So I do that a couple times, I end up at 270 degrees. Negative 300, well, that's negative. I need to make it positive, so now I'm going to add 360 on, and that gives me 60 degrees. So one person can rotate 60 degrees, another person can rotate negative 300 degrees, and they're both going to end up at the same spot. Do the same thing with negative 1020. I have to add 360 on several times until I end up with the first positive answer I come to, which would be 60 degrees. So once again, this is just adding or subtracting 360. That's a lot of what this first half of the lesson is. Can you add or subtract 360? Can you figure out what quadrant you're in? Other geometry concepts. Area and arc length. So if I give you a rectangle that is shaded, that's a quarter of the rectangle, and I would ask you how much of that has been shaded. Well, you can take 1/4 of length times width, because length times width gives you the area, and 1/4 of it is shaded, so you're going to multiply that by 1/4. Keep that idea in mind. How do you find the area of a sector? This pie shape is called a sector. That's obviously only part of the circle. Over here, we took a part of the rectangle times the area of a rectangle. To find the area of a sector, we need the part of the circle times the area of the circle. So we're going to use this formula. That symbol there is called theta. It's just a trig symbol that means the measure of an unknown angle. A full circle is 360. So this is our part of the circle. Pi r squared, that's the area of a circle. So if we multiply all this together, we'll figure out the area of a sector. So in this example, I tell you that the radius is 10 inches. Alpha is another symbol, like theta, that simply means the measurement of an angle. Our angle is 40 degrees. So if I put 40 in place of theta up here, fill in the rest of what I know, radius is 10. I can just use my calculator. There's a pi button on your calculator. Please use it. So multiply 40 pi 10 squared. This is division by 360, so I show divide by 360. Plug all that in, I get 34.91. We're talking about area, so the units for area is squared. We're dealing with inches, so it's 34.91 inches squared. Here's our next example. Radius is 26 centimeters. The angle is 96 degrees. Put that into the formula. use our calculator with the pi button, we end up with 566.32 centimeters squared. Our last example, notice this time I gave you the diameter. The formula requires radius, so we have to convert this to radius. Radius is half the diameter, so our radius is 20. There's our angle, there's our radius, plug it in, we get 87.27 feet squared. So that's if I give you the angle and the radius. You can find the area of the sector. I can ask you to go backwards. I can give you the area of the sector and either give you the radius or the angle and ask you to find the missing piece. So in this case, you're thinking algebra. Undo the equation to get down to your unknown. We know the surface area. We don't know the angle, so I'm going to put the angle over 360. And then pi r squared, where our r is 12. I need to get rid of this fraction, so I'm going to multiply both sides by 360. That gives me this. 12 squared is 144, so if I divide by 144, I come up with this decimal. I have to get rid of pi. Using my pi button on the calculator, divide, and I get approximately 30 degrees when I round it to a whole number. In this example, I've given you the surface area, I've given you the angle. Now I want you to find the radius. So plug that information in again, multiply by 360 to get rid of that fraction, gives us this. Divide by 120, which is our angle measurement, gives us this. We need to get rid of pi, so we divide by pi. Now this is what r squared is, 25.02 is r squared. We need r, so if we take the square root of it, we end up that the radius is 5 feet. Sector length. That means the length of the arc. So how do you find it? Part of the circle that we're dealing with times the circumference of a circle. 2 pi r is the circumference. So here's the formula we're going to use to find the length of the arc. Angle over 360 times 2 pi r. So this is going to look really familiar to the other side, just a slightly different formula. Again, using your pi button, plug everything in. There's your angle. Here's our radius. Put it into the calculator. We get that. We're talking about distance. Distance is 1 dimension, so it's just 6.98 inches. Here's the second example with the radius of 26 centimeters, our angle of 96 degrees. Plug it in. Using this idea in your calculator, we get this for our answer. Last example, again, notice I gave you the diameter. We have to find the radius, so we change that to 20. Plug all this into your calculator, you get 8.73 feet. As with arc length, with sector area, I can ask you to go backwards. If I give you the arc length and one piece of the information, find the missing piece. So here's arc length. We don't know the angle, so I'm asking you to find that. Plug everything else into the equation. Multiplied by 360 to get this. I'm dividing by 2 to get rid of the 2. Then I'm going to divide by pi, divide by 13. I end up that the angle is 70 degrees. Here I've given you the arc length, I gave you the angle. Now I want you to find the radius. So plug everything in, multiply by 360. I'm going to divide by 86, divide by 2, divide by pi, and we end up that the radius is 4 feet. So a lot of this is new terminology, thinking about placement in the coordinate system. Where are you in the coordinate system? To help you with that a little bit, if you go to the Algebra Planner, there is a link to a game that helps you place important angles in the coordinate system. You're welcome to use that to help you find degrees and get your mind thinking about where to place all of that. And then the last set of information was just using formulas to find arc length and sector area.